Hello, I'm Mark Miller, VP of Engineering at Daytrend Systems, and I am pleased to present to you the vPad-RF Automated ESU Analyzer. In this series of videos, we'll have a look at some of the features of the product and how to use them. In this video, we'll be walking through the vPad-RF software on the tablet. Other vPad videos describe the hardware and show vPad-RF being used in actual preventive maintenance inspections and other test situations. vPad-RF is a test instrument intended for measuring the output of electrosurgical generators, which are also known as Electrosurgical Units, or ESUs. vPad-RF includes an RF analyzer and a 10-inch tablet computer which has a number of software applications or apps installed on it. Two of the apps we will be seeing in this video are the vPad-RF app and the vPad Record Manager app. For this video, I have the tablet set to demo mode, which will allow me to show you how the software works without actually having to connect an ESU to the vPad. In videos to follow, we'll be using the app in real mode, which will enable us to perform tests on an actual ESU. The main menu of the app provides entry points to all tests and setup functions. Buttons along the top row access manual tests, HF output, high frequency leakage, and ESU REM or CQM alarm test. The middle row of buttons accesses automated test functions such as PM inspection procedures and power distribution curves. This button on the bottom row opens the operator's manual, which covers everything I will be going over in this video, but in more detail. The Test Record button launches the Record Manager app. We'll get into the Record Manager a little later in this video. Okay, so let's have a look at the manual HF output or power test. On selecting the test, a setup screen is shown, which displays a schematic of how to connect the ESU to perform the test. The schematic references a jack panel which is on the front of the RF analyzer. It's just a matter of looking at the picture on the tablet and then wiring up the cables with the ESU accordingly. With the Test Setup menu, I've got the ability to select different test configurations for monopolar or bipolar generator and internal or external load or combination load. The tablet shows me exactly how to connect the cables for each test situation. For more detail, I can press the Help button and read the written instructions. Foot switch control outputs of vPad-RF allow you to switch the ESU on and off automatically from the tablet screen. Now, if I want to test this way, the foot switch menu allows me to choose the ESU output port to activate, cut, coag, or bipolar, and also the ESU on time. Please note there's lots of different ways that you can choose to test an ESU with vPad-RF, and automated foot switch control is just one of those ways. Later videos will demonstrate some of these other options. For this video, where the tablet's been set to demo mode, foot switch control is the easiest way for me to show you how the software works, and we'll see this in just a minute. The HF load field enables me to set the load resistance for the test. The required value is typically specified by the OEM. 300 and 500 ohms are typical values for testing a monopolar output. Once everything's set up, I press the Start Test button to begin testing. If this is the first test since starting the app, you will see a reminder to keep the test connections away from the tablet's touchscreen. The ESU won't damage the tablet, but RF interference from the leads may affect the touchscreen if leads are in close contact. What's shown here is only common sense. The app will remind you of this once, and you won't be reminded again unless you quit and restart the app. Okay, so let's move on. So right now, with the display in the state shown here, vPad-RF is waiting to receive a signal from the ESU under test. I switch on my simulated ESU using the foot switch button. What we are seeing now are simulated measurements of RF current and power from a simulated ESU that's been set for 300 watts. After the foot switch on time expires, the readings are captured and are shown on a Save Data menu. A real ESU would then be switched off at this point. The Save menu allows you to create a record of your manual tests as you go along. Saving manual results is optional, and I can choose to dismiss the menu simply by pressing the Cancel button. Now, if I want to test and then create a record of my test, I can do so with the Save menu. With the Save menu, you can specify the ESU test condition, and you can select Pass or Fail for the result. As I proceed with my testing, I can have a look at what I've saved so far. The View Data button shows what is currently stored in the app's data buffer. At any point during these manual tests, I can choose to enter information about the equipment I'm testing and save a permanent record on the tablet. I'm going to do that later, once I've completed a few more tests. Buttons on the upper row of this menu allow me to change the test settings. The Analyzer Setup menu configures the digital signal processor in the RF analyzer. The Test Setup button returns you to the menu which we saw earlier. Here you can change the load resistance or the generator configuration. The foot switch menu is the same as we saw before and allows you to change foot switch control settings. I'll change this now to test the coag output of my simulated ESU. Also, I'm going to change the tablet from numeric readouts to an oscilloscope display. This time, when the ESU is activated, the actual waveform produced by the generator is shown in real time along with measurements of HF power and current, which are displayed on the right. Now in oscilloscope mode, when the Save Data menu appears, I've got an extra option for saving a screen capture of the ESU waveform, along with the measurement result for the test. Okay, let's switch the display from oscilloscope to spectrum analyzer. When the ESU is activated, the spectrum shows the ESU outputs most of its energy around 500 kHz, but with the ESU in coag mode, there's broadband frequency components that extend farther up into the radio spectrum. The spectrum shows how and why an ESU can be a source of radio interference that could adversely affect other nearby medical equipment. The oscilloscope and spectrum analyzer are particularly useful for verifying quality of the ESU output, and this is easy to do for sinusoidal outputs, for example bipolar or monopolar pure cut. This simulated ESU is operating nicely, but if its output amplifier was mistuned or malfunctioning, you'd be able to see harmonic distortion or noise components using either the oscilloscope or spectrum analyzer. Okay, so we'll leave behind HF output, and we will now move on to HF leakage testing. This is a type of safety test that verifies stray currents from the ESU to earth or ground do not exceed a maximum defined by a standard or by the OEM. This concept is similar to electrical safety tests with an AC supply, except these measurements are done at radio frequencies, and permitted limits are typically higher. The setup menu for leakage is similar to the setup menu for HF output. There are 7 possible setups as shown in the schematics. 6 of these are specified in the IEC standard, and the 7th one is a cross-coupling test, which is typically defined by the OEM in the PM procedure for the generator. The Help button provides written instructions to supplement the schematics. Once I've got the analyzer and the ESU connected according to the picture, I'm ready to test. Running a leakage test is similar to what we've seen before for HF output. When the ESU is activated, the current is measured and compared to the maximum limit. If it's less, the result is automatically assigned a pass. When the ESU is switched off, the leakage is captured and shown on the Save Data menu. I can choose the ESU test condition and save the result to the data buffer. As with the HF output test, the View Data button allows me to see what I've accomplished so far in my manual tests. I can save results as I go along, and then afterward, create a permanent record of the work I've completed. Now the next manual test I'd like to demonstrate is the Return Electrode Monitor or Contact Quality Monitor test. In this test, the REM or CQM port of the ESU is connected to the REM test resistor of the vPad-RF, as shown here by the help menu for this test. To perform a test, I vary the resistance and I observe the response of the REM alarm on the generator. Now, this is usually done following an OEM inspection procedure, which will call out specific resistances to be tested. Similar to other manual tests, I can save results to the data buffer. The result for a REM test includes the resistance setting and whether or not the ESU produced an alarm for that condition. If the ESU alarms as it should, I can assign a pass to this result. So once I've completed my manual test and I've saved some results, I'm ready to create a permanent record of the test on the tablet. At any time during these tests, I can go into the Equipment Information menu and input information about the ESU that I'm inspecting. At minimum, to create a permanent record of the test, I've got to enter an ID or a control number for the ESU. If I've got an equipment database installed on my tablet, I can do a database search after inputting the control number. Well, I don't have a database installed on my tablet, but I still manually enter the ID, and with these buttons, I can choose a make, model, and a location where the ESU is normally used. Now, these lists I'm picking from can be easily customized by you to suit your inventory and institution. With the ESU information entered, I can now create a test record. The labor time may be entered in hours or minutes. A next test due date can also be saved in the record, if desired. The Create Record button stores a report document in their tablet's internal memory. Test records saved on the tablet can be viewed, printed, and transferred by pressing the Test Records button on the main menu of vPad-RF. This button launches a different app on the tablet called the vPad Record Manager. The same app is installed and used on many vPad products, including safety analyzers and patient simulators. The Record Manager opens in the file folder where vPad-RF records are stored. The record I just saved is placed first in the file list, with prior records being listed in descending order by date. I can open the record, I can view results, I can convert from native format on the tablet into a PDF document. I can print via printing app on the tablet, or I can go direct to a printer via Bluetooth. I can also transfer records to my Windows PC with a USB drive, or by Bluetooth wireless, or even over the internet. Okay, returning from the Record Manager to the vPad-RF app, I now want to show you some of the automated test capabilities of vPad-RF. The first type of automated test I want to talk about is a power distribution curve. This menu shows there are a number of different tests to choose from. Power distribution curves appear in OEM specifications, and they show you how the ESU output power varies as the load resistance is changed. vPad-RF allows you to perform such tests automatically. To show this, I will select and run the demo test. After selecting the test, a setup menu is shown. This is similar to other menus which appear throughout the app. There's a schematic showing you exactly how to connect up the ESU for the test, and there's some written instructions. Once I've made the necessary connections, I can run the test with the Start Test button. You can see the general idea of the test from this menu. The test load is set to a predefined value. The ESU is activated, and in this case it's by automatic foot switch control. And the output power is measured and then plotted on a graph. vPad-RF allows you to program your own power curve tests, and these can include upper and lower limits for each power reading, as shown here. This test takes some time to complete, so we'll leave it here and we'll come back when it's done. With the test complete, we can see how the output of the ESU varies as the load on it is changed. Results appear on the graph as well as in the scrollable data table on the right. In this case, all power readings fall within upper and lower limits which have been defined by the OEM. So this test has been automatically assigned a pass. Save Test button copies the results to the data buffer, and from that point I can choose to save a permanent test record on the tablet, as shown earlier. Although I've been able to demonstrate a lot of amazing features in this video, perhaps the most important one is the ability to perform automated preventive maintenance inspections on electrosurgical generators in accordance with OEM procedures. And this is what I'll be showing next. To choose a PM inspection procedure or another automated test, I press the autosequences button on the main menu. This pops up a menu to choose a procedure for a particular make and model. vPad-RF is supplied with PM procedures for a number of makes and models, but you may need to inspect a different ESU. Well, that's okay. vPad-RF is an open system which enables you to write your own inspection procedures that will run on the vPad tablet. Daytime provides free software tools to streamline the process of creating your own PM procedures. I'll be explaining more about that after showing you the demo autosequence. When I choose a PM procedure, I'll be prompted to input information about the equipment being inspected. We've seen this menu before. I can choose to enter the ESU information now, or I can do it at the end of the test. I will skip this menu for now, because I'm more interested in getting on with the PM. If some of you are familiar with other vPad products, such as vPad-ES or vPad-Check, then you will recognize a certain way of doing things which has been carried over to vPad-RF. Inspections consist of a number of steps, done one at a time. Steps can provide specific instructions and prompt you to perform certain visual inspections where you will record a pass or a fail for each step. Inspections can be made to follow the OEM's PM procedure or the OEM's checklist for the ESU. Inspection steps can display photographs or schematic diagrams which show you exactly how to connect things up for a test. At this point in the demo, we begin to test the REM function on the generator. The instructions shown on the screen explain what to do for each test case. The criteria for what's expected from the ESU is incorporated into the procedure being executed by vPad, and this results in an automatic assignment of a pass or a fail for each step. A typical PM inspection will include a number of HF output and leakage tests. As these steps are encountered, pictures are shown that explain how to connect the ESU for the test. For HF output or leakage tests, the ESU can be activated automatically by foot pedal or manually by test pencil. Measurements are compared to acceptance limits defined in the manufacturer's test procedure. The results are automatically passed or failed and then saved to the test record. vPad then advances to the next step of the inspection procedure automatically. At the end of the inspection, I'm prompted to create a permanent record of the test on the tablet. As we've seen before, I can enter time spent on this inspection and enter a next test due date for the record. Now, earlier I mentioned something about creating your own PM inspection procedures, such as the one we just saw, but for ESU makes and models that you may have in your inventory. What is being shown here is vPad IDE running on a Microsoft Windows computer. vPad IDE is an integrated development environment. It's a software tool which you can download from the Datren website for free and which will enable you to write ESU PMs that run on vPad. vPad IDE is provided with a set of example PMs that you can use as templates to develop your own inspections based on OEM service manuals, procedures, and checklists that you currently have and are using to do your inspections. Go to the Datren website and download vPad IDE now. Try it yourself and see what I'm talking about. Keep watching Datren YouTube channel for upcoming videos on vPad IDE. In summary, vPad-RF is the smallest full-featured analyzer for testing electrosurgical units, or ESUs. Based on Datren's revolutionary VisionPad platform, each unit comes with a built-in HF digital oscilloscope and spectrum analyzer. In this video, the vPad-RF app on the tablet was demonstrated. We saw simulated examples of manual testing as well as automated tests, such as power curves and PM inspection. This video was made with the tablet running in demo mode. Future videos will show how vPad-RF is used in real mode to test and inspect actual ESUs. This is Mark Miller signing off for Datren Systems. Thank you for watching.